Okay, there are more people coming. I'm very excited about this. But you know, one thing is, you know, treat it as a conversation,
Okay.
right? Because
Yeah.
all, you know, it's not even a presentation. It's just like, hey guys, finals are over. Let's do something fun.
Yeah. No,
Right?
for sure.
I think everybody suffered a little bit, you know, this year. You know, that is like, oh my gosh, we got all these online classes, and you know, we can't see our friends and all that. So
Sorry.
you know, treat it like a show, you know, of some sort. You know.
Yeah, you cut out for the last like 10 seconds there. Could you repeat that?
Yeah, I was gonna say, just treat it as a social gathering of some sort. Yeah,
Yeah, totally.
yeah. Okay.
Yeah.
So okay. Let's give it 1 more minute, and then we're gonna let people in. Okay.
Yeah, sounds good.
Yeah. Actually, about 46 people now. Wow, that's a
Whoa.
lot. Yeah, I'll be back.
Yeah.
Daniel, your talk is gonna be the most number of people. We got almost 100 people.
Whoa. Okay.
It's
I didn't
crazy.
expect that.
I didn't expect that at all. But
Okay.
whatever, right? We're just gonna have a gathering. It's Christmas time anyway.
Yeah,
All right,
that's
you
whatever.
ready? I'm gonna let people in now.
Yeah, for sure.
Yeah. Oh my goodness. Everybody, welcome. Welcome. Please show your camera. Okay. All right. Welcome. Please show your camera. Wow, this is crazy. This is crazy. We have, guys. Oh my gosh, we have 100 people joining us. I have never had this many students coming together. All right. Okay. Officially, we're all full. Okay, we're all full. We got 100 people here. Okay. So how's everybody doing? Like, how's your final? Your final is over, right? By the way, if you first came in, please mute yourself because there's so many people here. Second thing, I need you to.
Oh yeah, Michael, it's you're cutting out.
Okay, show your camera, please. Okay, hey Daniel, why don't you take over, because I think your internet is gonna work. My internet won't work. You go ahead and take over. Introduce yourself and all that. Yeah.
All right, let me see. Can you guys all see my screen? It's working?
Yep.
All right, perfect. So hi everyone, I'm Daniel. I'm gonna talk a little bit about myself before I get into this, but so I'm a senior at Kahila Jewish High School in Palo Alto, California. I love it here. It's amazing. I'm big into chess and music. If there's any chess players here, I love the game. I hope you guys enjoy it too. And I've been working. I mean, I've always been interested in like math and computer science stuff, but I've really machine learning has been my thing since the beginning of high school. And so I'm here to talk to you guys today about pursuing your interest in machine learning and like why it's important to do like these passion projects. So to give you a little context, one summer, I think it was going into my sophomore year, I found out about this program called AlphaZero. And for those of you who don't know or aren't big into the chess world, computers are much better than humans. And so there's a program called Stockfish, which is like kind of considered like the pinnacle of computer chess in a sense. It was pretty much unbeatable. And so I remember like very distinctly, I was browsing YouTube at like 1 in the morning in the middle of my summer vacation, and I saw all these YouTube videos all of a sudden. about how like Google's new DeepMind AlphaZero thing completely annihilated Stockfish. And for me, this was like fascinating. I was like hooked, right? Not only did it like destroy what I thought was like the best program at the time, but it also played in a really human way. It was like completely, as a chess player, I was like completely hooked. And so I went in a little more and I actually decided to explore more. And quickly I found out that, so DeepMind was very secretive about this program. They didn't release it to the public. There were only a handful of games even available. And so I was kind of pissed. I don't know about you guys, but like if something as like crazily monumental and like impactful as like changing the whole chess world's AlphaZero is not available to everyone to see, I was like, maybe I can make my own version. And so quickly I kind of realized that I was already interested in machine learning. And so I figured, hey, why not give this a shot, you know?
Daniel, I got one question for you. So before you dive into, for example, machine learning and stuff like that, did you how did you learn programming by yourself? You know, how did you get to know programming?
So I remember like I think it was in 4th grade. I don't know if you, I guess, familiar with Code HS. Do you guys know what that is? It's
high school.
Yeah, something like that. It was a program that came to my school, my elementary school, and they taught people how to code.
Yep.
And I learned JavaScript for the first time, and I was like, whoa, this is crazy. I remember making like my first games with my friends. And ever since then, I was like learning Python and all these things. And I had like worked on a lot of CS projects in middle school. So by freshman year in high school, I was already like pretty well familiar with coding. My dad also helped me a lot because he's a computer scientist.
So these programming stuff sounds like you learn everything on your own.
Yeah, definitely. And I'll get into that more, but the internet I found is like amazing to learn anything.
Right.
As long as you look in the right places and you know how to parse the information, you can learn anything.
Can you actually just deviate a little bit, you know, from this whole thing? Because this is one of the point we're trying to make here. That is, if you want to learn these things, you can. Can you actually like? Is it possible for you to maybe recreate your learning journey? Like, let's just say you want to learn JavaScript. How did you go about learning that?
So I mean, Code HS is free online, and I would just like go in and just work on it in my free time. I wouldn't spend a whole lot of time, obviously, because I was like, I remember when I was in 4th grade, I had a very short attention span. But I remember every now and then I'd slip in a little bit of JavaScript and I'd learn the syntax and I learned the fundamentals. There's also like great resources like Codecademy. I mean, even just Google searching, learn JavaScript free. I mean, for me personally, that was enough. And then afterwards, after I kind of found that I was interested, I started looking more into resources I had in my personal life. So like my parents, my school. But honestly, it was really like, it's really simple. You just need to learn to ask and to understand that you're curious. I think that's the big thing. So yeah.
Daniel, I hope you don't mind. So I'm just going to turn this whole session into like, you know, a conversation, right? You know, doing a presentation, I think is great, but also like, you know, having a little bit of conversation that will help people, you know, understand, you know, your journey.
Yeah, totally.
Okay. All right. Go ahead, man.
Yeah. So this AlphaZero stuff, I was completely hooked. I was totally curious. And so I guess one of the first mistakes I made when I was trying to learn about AlphaZero was going headfirst into the paper. I don't know. I'm personally not familiar with enough math to understand what any of these things mean. I understand like a logarithm maybe, or like I see a square symbol, right? But as a freshman, I was like completely turned away by this. And this kind of scared me, seeing like words like spatial planes for flat vectors, this stuff like it's very mathematical and complex and nuanced. And honestly, in my opinion, you do not need to know what a spatial plane is to code these things. Writing code is a lot easier than it seems. And you don't need to have like know all the intricate mathematical nuances of these things, in my opinion. And so one of the first things I did to actually try to understand what was going on with AlphaZero is I saw in the abstract, there's a term called reinforcement learning. So I looked it up on Google, I looked it up on YouTube, and I found these lectures. And obviously these are crazy 1.5 hours long each. They're like really, really in-depth and complicated. And so I didn't really, these are more kind of impressionistic in a sense. Like I was a lot more focused on understanding the terminology and the background of these things, instead of actually understanding the specifics of the Bellman equation or whatever. And so these kind of serve as like a background research, I guess, phase for me. And I do this every time I try to understand a new concept. I look it up on YouTube. I try to find YouTube videos explaining it in kind of a way that's I can like understand. And so I didn't watch all of these lectures to the T and take notes and everything. But you know, every now and then, if I was washing the dishes, I'd put it on in the background. I'd listen. I'd get familiar with the terminology. And this kind of helped me move on to the next step, which is actually like specifically looking into AlphaZero. Once you kind of understand the general, and you don't, maybe if you already have a good background in machine learning in the specific subtopic, then you can just go straight into this step. But like understanding like specific articles and guides that help like break down into English what the paper is saying. And these are by far the most important step in my opinion. They help you really gain an understanding of what's actually happening.
So Daniel, I have another question for you.
Yeah.
Because like reinforcement learning is something to us is like it's almost like maybe like a second step, maybe even third step, right? Because the first step would be like getting all the programming stuff right. Sounds like you already got that.
Right.
But then there's another step in between, which is basically like machine learning itself, right? And
Right.
deep neural network by itself. And when we look at, for example, reinforcement learning, a lot of times these agents, they are neural networks. So I wonder, like, how did you gain that kind of like fundamental understanding of neural networks?
I can actually show you really quick where the exact videos I did watch.
Please, please.
Okay, let's go to YouTube. There's a channel on YouTube I love called SentDex. This guy is amazing. He has so many tutorials on just getting into Python, neural networks from scratch, everything. Wow. And so I remember the same summer, I actually went into this guy's YouTube channel and like learned all these things. There's also Udemy courses, which I used. And I obviously, all these courses are really long. So it's more of a scraping by and kind of skim reading in a sense. Right. It's not like I'm like in a class, I'm trying to pass a test. But it's more like getting familiar with the terminology and understanding the intuition behind things.
Right. So I actually think like that learning mode is gonna be the main learning mode as we grew up. Because when I was in my job, if I don't know anything about some subject, I would actually go and just like what you did. Like I skim through things. I understand, for example, just a framework, not everything in detail how it works, right? And then at least you know what this thing can do, and then you try to implement something, and you're missing some details, and then you would learn the details within each, I think.
Right, yeah. As long as you understand the general broad strokes, you can fill in the details as you go.
Right.
Exactly.
Right. Okay. So another question I have, as you're going through this journey, are you doing this by yourself? Do you have like your dad? Do you have like some good friends? Any clubs? Like any like I would say maybe like people going along with you?
Not really. My dad is always kind of in the periphery because my dad is very into this machine learning stuff. It's like his job. So I'm kind of lucky to have that as a resource. But when I started, I especially just went by myself.
Wow.
I was already very familiar with like researching things on YouTube and things like that. Like, I mean, I've interested in a lot of things before. So I kind of knew that like the internet, I mean, I've grown up on the internet. So I've known that it's a good resource to look things up.
Right.
But I guess, yeah, I haven't really used my in-person resources as much as I probably could have back then.
Got it. Okay. Thanks for sharing. Yeah.
But yeah, so after you're kind of familiar with the intuition behind things, not necessarily why they have a logarithm here, or why it's like the magnitude of this vector here or whatever, you can then go to the abstract. I mean, you can do these in whatever order you want, but I prefer to go to the abstract after I understand everything. Well, understand. It's more of like a intuitive understanding, but once you like read the abstract, then you can kind of get a sense of like, okay, now I know all the vocabulary-ish. I understand what's happening on like a more specific level to AlphaZero. And so these are the steps I took before I actually implemented this. And obviously you can still go in and read the paper afterwards, but unless you have like a bajillion college degrees and like you're a genius in math, like, I don't know, the math scares me sometimes. So I try to avoid getting really deep and nitty gritty.
And your goal is not to, for example, like understand everything, right? Your goal is to use AlphaZero for your purposes, right? Is that right?
Yeah, and the goal was, I mean, for me at the time, my goal was just like, I want to play chess. I want to see how this thing works. I want to like play chess against AlphaZero.
Right.
So I didn't really care if like I'm missing like oh, maybe like my equation is very slightly off. If I get like a good chess engine, that's all I'm concerned about, right?
Right. And so when you try to implement this thing, like, okay, we understand that you learn machine learning and deep learning on YouTube, like, sounds like there's some very good resources there. But did you actually like implement like any machine learning or deep learning stuff before you get into this?
Uh, a little bit. In my freshman year CS class, I don't know why they made me take the introductory class, and so I was already CS was like definitely my strongest subject in school, and so
Right.
I had a lot of free time just relaxing, not really doing any work, because I was really done with everything. So my friend Jasper, we built this. It was like my first machine learning project. It was we decided, if you guys know what Discord is, we made this chatbot, which is
Yeah.
meant to be like detect bullying. It was super janky. I didn't know any machine learning. I just asked my dad. This is probably the first time I asked my dad to help me with something
Right.
about machine learning. But so what we did is we went and like manually looked at comments on Reddit threads that were like really mean, and we put them in and labeled them as like mean comments. And we
Oh,
wrote our own custom nice comment.
wow.
It was very like janky and like put together, but it was something, you know?
Yeah, that's pretty cool, right? I mean, because then you can flag these comments, right?
Right. And so then I just did some scikit-learn logistic regression or something like that. And
Whoa,
I
can you show people what's a psychic learn?
scikit-learn?
Yeah.
Oh yeah, absolutely. Scikit-learn is like my best friend.
Yeah.
So scikit-learn is this Python library, and it has anything that's not a neural network is probably here. So if I want to find the logistic regression, it's right here, and I can maybe it
And you
shows
can
me.
learn how to use it, right?
Right. If I do
Yeah.
like, yeah, so I can just from scikit-learn.linear model import logistic regression, and then
Right.
it tells me how to use it and how to code it right here. It's pretty
Wait,
simple.
is down below? Down below, there must be some examples, right?
There definitely are. Yeah, exactly.
Yeah, here we go. Here we go. So this is a classification algorithm, right?
So this is the famous iris data set, which basically has a bunch of pictures of flowers, and it has like information about them. And
Yeah.
so what this is doing is saying, okay, I'm gonna make some classifier. That's called logistic regression, and I'm gonna train it on this data from the iris data set, and then I'm gonna predict whether like which type of flower is from the training set, like I guess
Right.
it's the first two. I don't
Right.
know.
So
Um,
sounds like here like you have to basically like load the comments and get some features out, and then you can do a classification on whether they're mean or not, right?
right.
Okay. Okay. And tell me again, why, for example, why not do this on your own? Why you have to team up with another friend?
Well, so the thing is that I did all the machine learning stuff. He did all the Discord stuff because he is very good at like writing, like working with APIs and things like that. I was really
Right.
unfamiliar with it, and I figured that it was a good division of work, and we were both kind of
Yeah.
not really supposed to
Yeah.
be in class.
You know,
So
in companies, actually, there's such a division as well. So your title would be like a data scientist, and his
mhm.
title would be an engineer.
Yeah,
Yeah, it's very, very similar. Okay, that's awesome. That's awesome. And I guess, when you're working together, going back and forth, that made the whole thing more interesting.
yeah, definitely.
Yeah. Okay. Awesome. Yeah. I think that's a really, really good mode. Okay. Yeah. Thanks for showing us. So it sounds like sklearn is this machine learning library. Okay. Got it.
Yes.
Okay. All right. Okay. Please go on. Yeah.
So yeah, so definitely, and that was pretty much my only experience up until then. I mean, that project it got me really interested in machine learning, though. Like that was kind of like the spark that started it all because I was already I had heard the term before, and I started that thing and it's like, whoa, this is really cool. I can make a bot that can like predict how mean your comment is. I don't know, it just seemed really interesting to me, so that's what kind of fueled this project, which then fueled a bunch more. But anywho, um before I move on, I also want to actually explain to you guys how AlphaZero works. I think it's a super fascinating algorithm. um so basically, I'm sure you guys are somewhat familiar with supervised and unsupervised learning, which is like you have a data set, you have some labels, and you say, okay, I'm going to predict if this is a flower or if this is a car, if this is a tree or something. Reinforcement learning is kind of like their distant cousin, in my opinion, which kind of frames machine learning in a different way. How it works is this is a kind of a very complicated diagram, but there's an agent here, and an agent in this case would be like my chess engine AI, and it would take an action in an environment. The environment in the AlphaZero case would be the chessboard, and so the action would be like, hey, I move my knight to this square, So once an agent takes an action in the environment changes somehow according to some rules. And what you get out is a new state, so the new chessboard after you've made that move, and maybe some reward. So if I won the game, that would be a big reward, like 100 points. If I lost the game, maybe it's minus 100. And so this framework,
every single move, there will be some kind of reward.
not always. Sometimes it's at the end of a game. It really depends. This is a super, super general mathy framework that's supposed to work for tons of things.
Right.
So they very loosely and generally defined it.
Right.
But the cool thing about reinforcement learning is if you can slot all the pieces of a problem, like, oh, this is my agent, this is my environment, these are my states, and these are my rewards, these are my actions. If you can kind of find pieces that fit into that framework, you then get a bunch of cool formulas. And I don't really know I kind of know what these mean now, but back then I definitely didn't know what Q of S and V of S really meant. But what I do know is that you can use them to solve problems. So the Q of S and V of S and all these other functions are kind of afforded to us by reinforcement learning, which is what makes it super cool. You can actually like maximize your reward or solve environments. So it's a really cool framework. The problem is that you need to go through every possible state usually to make these things work. So for like this maze game on the left, right? This mouse, if you represent a state as a mouse being in any one of the squares, there's about 100 squares, so about 100 states. It's pretty easy to like calculate all the possible states and do all the calculations necessary for those formulas. For chess, it gets a little more complicated. If you wanted to use all those reinforcement learning algorithms in a chess game, there's about 10 to the 120 states, which is like bajillion times more than how many atoms are in the universe. So it's computationally impossible to actually apply those formulas here. So reinforcement learning researchers and chess people took it to the drawing board, if you will. And they developed something called a Monte Carlo tree search, which I'll explain now. But before I do that, I want to ask you, if I wanted to ask you the question, how good is this position? How do you think you would go about it? What Monte Carlo tree search does is it essentially says, okay, a position is only as good as its possible continuations, right? So if I have this position,
you want to think.
Sorry, you cut out.
All the steps follows, and how does this move actually give you better winning probability and things like that?
Right. So a chess position is only as good as its possible continuations, right? If all the possibilities are really bad, your position is probably pretty bad.
Right.
And that's kind of the underlying assumption here. It basically looks at each next possible state and says, how good is this move? But then you run into a problem, right? It's kind of asking the same question over and over again. So once you like go to the next stages to each of these individual moves, how do you actually check how good each one of these moves are? So this is where Monte Carlo tree search comes in. And this is a complicated diagram, but what it does is it does this. So if you look on the left here, where it says selection, there's a little tree, and the top of the tree is called the root node, and that's like your current position. And what the Monte Carlo tree search does is it finds a new node, right? So it gets maybe one move ahead, two moves ahead, and just makes random, or not random, it selects them. There's a certain algorithm to do so. But it essentially looks ahead a couple moves, and then it expands that tree. So it makes a new move from that position, and then it plays, let's say, 1,000 random games. And let's say in the position on the top left here, out of those 1,000 random games, after you move through the tree and simulate, black wins 68% of the time, right? Okay, cool. Now let's say in the bottom one, black wins 21% of the time, right? You can do this for every single possibility, right? You can say, oh, I can simulate after this move, I can simulate 100 games. And generally speaking, if black usually wins in all these possible continuations, black will probably also be in an advantageous position. So that's kind of the underlying assumption of Monte Carlo tree search. It's basically saying, okay, if we simulate a bunch of random games and black tends to win more, then black is probably in good position. And so it's a cool idea. It works for some games, but the problem is that even now, the chess still has so many possibilities, right? If we go back here, I went on my board and I made like 6 possible moves, but there are like 100, right? And like not actually, but there's like so many possibilities. It's still pretty computationally not feasible to do this and have it work because you need to go through a lot of possibilities and simulate a lot of games each time. So it runs very slowly. So what researchers did is they kind of used a trick. So in chess, if anybody is a chess player here, you know that like most moves that people like that are possible are junk, right? The moves I showed on the left here, 2 of them will instantly lose the game for black.
Mm.
And in general, most like positions, like if you have a chess grandmaster, it's like the best in the world, he's generally only going to look at 5 or 6 moves at any given board position. There's a way to kind of trim down all the junk, and that's what researchers kind of did here in this tree search. Then this formula on the left is kind of complicated, but it essentially just says it's a way to tell you how good a node is or like a position is. So if we go back here to the selection phase, they essentially use this formula on the left to choose which nodes are not junk. They say, okay, this is probably a decent position, so we're going to simulate this one. And it creates these really lopsided trees. If you look on the right, this is actually from AlphaZero. And you can see the darker black spots are places which have been simulated more. And if you notice, it seems like the positions on the right-hand side of the tree are a lot better. So they're simulating them a lot more. So this is kind of a way that researchers found to like kind of trim the search and make it a little easier to predict how good a position is. The problem is that it's still too much. There's still too many possibilities. And so this is already existing research from like the 2000s. And what AlphaZero is coming in and saying is, okay, instead of manually simulating each one of these games, we're going to create a data set where we're going to have a position and simulate a bunch of games. And the target variable is going to be the win percentage. It's kind of, I'm simplifying here. But so they essentially use a neural network to predict what the win percentage would be based off a position, if that makes sense. So if we go back here, you'll basically like do a bunch of random games and you'll find, okay, for this position, black wins 68% of the time. For the bottom left position, it'll be 21% of the time. For the middle one, it'll be 4%. And you'll have a billion examples of that. And then you can just train a neural network to learn that mapping between position and win rate.
Okay, so you're saying essentially the inputs are essentially one particular board,
Yes.
and then the output is essentially the winning percentage.
Kind of, yeah.
And when you look at that training thing, where's the training data come from?
It plays against itself. That's the coolest thing. So it actually just all these simulation phases here where it just randomly plays out games, it's against itself. So it essentially kind of uses I think of it as like reinforcement learning here, the actions and the environments. That's how you generate your data set. You don't use the math, you just use it to create a data set.
Do they actually use like games that people already played? Do they use those data to first maybe train the network so that you can have board position to winning percentages?
I have heard of that being done, but I think so that's transfer learning, I think. And I don't know how well developed it was back then in 2018. I mean, I'm sure they could have tried it, but I also think that the thing is that I think as long as you explore, as long as you have the right like kind of algorithm to choose which positions to look at, it doesn't matter your starting data set. I think it's also kind of better that it learns by itself because then it could come up with rules that humans might not have invented.
Never thought of. Yeah. Okay.
So that's my understanding of it. And yeah, I mean, that's pretty much all there is to the best chess engine in the world. It's not that complicated. Unlike what the paper might make you think. And so the coolest thing about this is that it's not just for chess. It works for Go and it works for Shogi. It actually works for any 2-player game where you have what's called perfect information. So if I'm able to like do those simulations, right, where I know all the possible moves and I know all the rules of the game, and it's like essentially you know all the information about the board, then you can apply this AlphaZero algorithm to it, and it'll be incredibly good, like superhuman. Where this doesn't work is like poker, where someone can bluff and there's not perfect information. When you simulate games, there is not like a deterministic like this is exactly how the game works, if that makes sense. And so it's really cool though. Like these people pretty much solved, I mean, we don't know if they solved Go, but they are chess, but they've made a really, really strong algorithm. And so after understanding this, I was like, okay, now I know how this works. I'm gonna try to make it myself. And I ran into a few problems. The first was that I was trying to run this off my 2015 MacBook Pro. And Google had been using like hundreds of thousands of dollars of GPU hours. I really couldn't compete with all the I guess cloud computing that they used. The second thing is that I wasn't familiar with the specific library to code neural networks, TensorFlow. At the time, I'm still not very strong on it, but I never learned anything. So like all my YouTube tutorials and stuff, I had to essentially learn what kind of felt like a new programming language at the time. So I ran into a lot of bugs and issues, and it was just kind of a pain to code it. And I also, there were still some specifics and details in the paper, which I never really fully got. And so I tried to simplify them. Like the way they represented the boards, for example, like in memory, it was like the big tensor with a bunch of arrays and a bunch of things. And I didn't really understand how to do that. So I did a lot simpler things, which I think ended up hurting the performance. And in the end, my AI was able to play chess, but just not very well. It only beat like random. I had it play against a random agent where it would just make random moves to kind of test benchmark how good it was doing. And it beat it like 55% of the time. It was pretty awful.
So this whole journey here, just so that we understand the time frame, like how long did that take for you to like first discover the problem and then till the first implementation? How long did that take for you?
I think about like the first draft, my first implementation from start to finish, maybe like 2 weeks, 3 weeks.
Weeks. Okay.
And I wasn't spending, I probably could have done it in a few days, but I kind of spread it out because I was on summer vacation. I wanted to travel and see friends and all these things. And so there was, I was a little distracted, but I definitely did spend some time on this. And I was, I think understandably like annoyed that it wasn't working. I was so interested and I really thought I understood this thing.
Right.
So I thought like, okay, I can put this, why isn't this working? And so after about a month of like not really getting anywhere with this project, I just abandoned it. I figured I was ramming my head against the wall. It was done. Like I don't have the capacity to do this anymore. And actually for people, I remember people would ask me what I did for summer and over that summer, and like I would just avoid talking about it. Like I just didn't want people to know that I thought I had failed. So I didn't want people to know that I'd spent my summer like not really doing anything productive. I mean, not actually coming out with a product.
Right.
So, but thinking about it, like reflecting on it now, I don't think I ever really failed. I think that project was a huge success. The first and most important thing is that I walked away with knowledge of like a whole field of machine learning that I never knew before. I never thought I could even touch it. And now I felt like I had a decent understanding of it. And I actually was able to apply it to other projects. Like I had this Connect 4 project I did in my algorithms class in junior year, where I had to code an AI to play Connect 4, and I used a lot of the similar concepts I learned here to make that agent work. And so I also learned kind of how to research. I mean, I already kind of had an understanding. I could go and type things into Google before, but like knowing which specific articles or which websites generally had good data or information. I don't know, like I just kind of gained like a better understanding of how to research these things and how to like bog and boil down really complex ideas. To think that was like I could chew off, like I actually understand.
Right.
And I was also motivated to start other projects. I remember at the beginning of the next school year, I made this like, I think it was an RNN. I'm not 100% sure what the neural network was, but it was like a language modeling thing, kind of like Transformers do now, but before Transformers. And I've done plenty of projects since, but so that kind of gave me that drive, like, hey, I can actually like understand these things. Even if I don't always succeed in implementing them, I walk away smarter.
And so I'm going to ask you a few tough questions. Okay.
Sure.
I wonder, like, when you're going through this journey, when you look back, like I think it's totally cool. You learn so much, walking, from this. But I guess, one of the questions I have is like, in retrospect, right? Let's just say, you're going to redo this, right? Redo this. You now with the knowledge that you have, what are the things you would do differently?
I think what I would do is I maybe would have tried to simplify the project more, because implementing the like full Google, like at first, like understanding it, I would have done the exact same way.
Right.
But when it came to implementation, I think I could have kind of like stolen, or like not stolen, but like kind of taken some of their ideas, but made it into a much simpler product. It wouldn't be.
Can we quickly do this right now? Let's just say we go back to that day. Okay, and now you got all these knowledge about reinforcement learning, machine learning, understand different concepts. We just say today, like right now, you're gonna start a project for reinforcement learning. How would you go about it?
The first thing, I mean,
Can we simulate? Maybe you can Google search and stuff. Like, let's see how you would go and approach it.
oh, something that I really like going for reinforcement learning, if you guys don't know, it's called OpenAI Gym. They have
Ah,
the environments here.
right,
And so it's essentially like if I want to play like Space Invaders right here, or this like asteroid landing thing, these are all like they're like kind of custom environments that OpenAI has developed and allowed you to write code and interact with really easily.
right.
And so what I might start off with is just play around here and see if I can solve one of these environments. I mean, there's tutorials online, right? If I want to see
Right.
OpenAI, like cartpole, Q, and Q learning is a term in reinforcement learning.
Yep.
But so here, I could like look this up and see someone's probably implemented this, and I can see how it works.
So you were just basically using the existing tutorial, walk it through first, lower
Right.
rank.
So
Okay.
right, kind of like
Okay.
training wheels.
Yeah.
And then also, I mean, it's very explanatory too. I mean, I've actually done this before.
Yeah. Yeah.
But like these are very useful tutorials which actually explain
Yeah.
a lot.
Hey, let me tell you this. I never took any classes in reinforcement learning, and like when I approach like learning about reinforcement learning, this is exactly the same approach that I took. Yeah, and as a matter of fact, I actually started like reading a book. I guess I'm just old. I actually like found this book. It's really cool. I actually sent in the chat. This is not advertisement by any means, but this is the book that I read. I went through, and you know what? It's exactly what you're suggesting right now. Which is basically like starting with very simple example, like cartpole example, and then you go through some other algorithms until all the way you go to the Bellman equation and the deep reinforcement learning and stuff like that. Yeah. So
Right.
it's like
Exactly.
it's like a shallower kind of ramp going through because it sounds like what you have done is almost like okay, today I'm gonna start climb like rocks. And the first thing I'm gonna do, I'm gonna go and climb El Capitan. Right. And
Yeah,
then
that's kind of what I thought I was. That's kind of what the beginning AlphaZero idea was. Like, yeah, I can climb Mount Everest. I understand how people climb.
yeah, but you know what? That was both daring and also one of the best things that ever happened. Like let me tell you this, right? Like yesterday, I was actually listening to a podcast. You guys know the game League of Legends? Do you guys know that? Okay, so the founder was so young. They were like 25 or something at the time they were doing this, and they were like, you know what, we're just gonna go build this thing, and then they ran into like so many troubles, and in retrospect they were like, if we were industry expert we would never start because just too hard. Yeah, and it sounds like what you have done here is also like having that kind of naiveness, but however you went ahead with it and you learned so much out of that. I think it's really cool journey you shared it with us. Yeah. And I really want to encourage everyone here, right? Do something that's daring, do something that's difficult. You don't know how to approach it, but look what Daniel's done here, right? You basically systematically like dissected that problem, right? And then you learn all these materials, one by one. Oh my gosh, this is I would say this is one of the best guest talk I ever had. Yeah,
Thank you.
it's awesome. It's awesome. Okay. All right. So you would go through the gym, but let's just say you go through the gym and you found there are a bunch of concepts you don't understand because there could be like Python stuff. Could be like involve neural network and that kind of stuff. I guess you answered this question already. You pretty much just going to go back to like YouTube or tutorials online to learn those things. Yeah.
Right. If I want to, especially like Medium is incredible. And by the way, Medium has a paywall. If you guys look it up, there's actually a way to get past this paywall, which I've thankfully found very early on in my machine learning career. And you can find it if you just Google it.
It's only $5 a month. Guys, buy it. Okay. Support that organization. Medium is a great organization. Buy it. Yeah.
that too. But so Yeah, I guess the thing is like going to Medium articles, even for like neural networks or like simpler machine learning concepts, is also like just as useful as this,
Right.
right? If I want to say, how do neural networks work? Oh, also for specifically for neural networks, if you guys know who 3 Blue 1 Brown is,
Yep.
this guy is like incredible. This guy has like inspired me so much for math and like science and
He makes
everything.
the best like tutorial videos like for math related
Incredible.
subject. Yeah, incredible. Yeah, incredible. Yeah.
This video I watched in the beginning of my freshman year, and it completely got me hooked. And well, one of the reasons I got hooked into machine learning was because of this video.
This video is something where every student AI camp should watch at least 3 times.
Absolutely. And there's a whole series too. It's not just, and also all the math you need to understand this video, this guy also teaches. So if you go here, not only does he have really cool, like kind of like Fourier transform, like you don't really need to know that for machine learning that much. But like these videos, the essence of calculus and linear algebra, oh my God, watch them.
Yeah.
100% recommend.
Yeah.
These will give you like, because some of these, like for neural networks, for example, to understand like a little more intuitively like what gradient descent is doing, you might want to know calc and linear algebra, things like that, but they're not necessary. But yeah, no, 3 Blue 1 Brown, absolutely recommend. Also, just like aside from machine learning, just as a content creator, absolutely support that guy.
So let me ask you another question here. So these concepts high schools will never teach you.
Oh, absolutely not.
Okay. And you went through a pace that's also like astounding, right? Because when you talk about when you first looking at this problem and then you go ahead and try to implement it, it was in a matter of weeks, right? In a matter of weeks. So can you maybe reflect and contrast a little bit, the learning style you're having in school versus the learning style you're having here, the pros and cons for each?
Right. I guess so. In my school, we had essentially 2.5 CS classes. We have the intro to CS and the APCS. And then sometimes they have this algorithms class that comes
Right.
after APCS. And so
Right.
APCS is kind of like the only real CS. The intro was kind of to teach you the fundamentals of like, this is an if statement, this is a for loop. And then APCS is kind of like what you'll find anywhere across America, which is like, hey, this is Java. You're gonna learn how to do like 2D arrays, and you're gonna learn how to like it's like more like basic programming knowledge.
Mm.
It's very like mechanical, I guess, and it's
Mm.
very like compartmentalized. Like we're gonna learn about 1D arrays here and 2D arrays here, and now we're gonna learn about while loops or whatever.
Mm.
That's okay, and it does serve a purpose into like training. It's very like utilitarian in a sense. It like helps a lot of people learn pretty effectively. But for me personally, I hate that stuff. I like
Mm.
learning at my own pace, and I like just like if I'm interested in something, I'll just like Google search it, and I'll just like fall deep into like this like phase, where I'm just like constantly looking things up and trying to understand, and like
Right.
fidgeting and experimenting.
Right.
And so I feel like at my school, and I think at a lot of schools, like teaching machine learning and like computer science and stuff, I feel like some of it kills creativity. It's very like I know for APCS, like it was a lovely class and I loved it, but there was a little bit too much of like teaching for the test, and that's I think what's
Mm.
present in every school.
Yep.
The nice
Yeah.
thing is that I kind of like me and my friends kind of banded together and asked them to bring a third class for us for my junior year. It was actually super fun. It was self-paced. We did projects similar to machine learning. Actually, we did a little bit of machine learning, but that was kind of specific to my school, and I don't think every school is going to have that. I'm kind of lucky I got that experience.
Mhm. Mhm.
But so yeah, I think the way ML is and like computer science really is taught in schools is very like mechanical and not what I
Right.
like. I don't think it's very good to foster like curiosity.
Yeah. Yeah, because that sort of like stop you from even getting more interested in these kind of stuff, and also stop you from like learning how to learn, right? Because it's pretty much like someone is preaching you about, oh, okay, here's A B C D E F G, as opposed to like, I wanted to solve this problem, I wanted to learn all these things. And by the way, like these knowledge they're created like very recently, right? It's not like for example, like we're gonna have world expert who has like 50 years experience in this thing, right? Okay.
Right. It's all in the past decade, pretty much. Well,
Yeah.
the deep learning stuff,
Yeah.
anyways. But the thing is that, in my opinion, like at least I remember in my APCS class, people would like. It's so weird to me that you have a test for computer science because in
Exactly.
actual coding, right? in these projects or whatever, if I get something wrong or if my code doesn't run, I'm not going to get a 0 on that like question. I'm going to look it up on Stack Overflow and then someone's going to help me fix it. And the thing is that like on a test, if you like you don't put a bracket or something like that in your test, you could get a 0 on that question. And that doesn't make sense. It's not like actually how practically computer science work. It's not like you submit it once and then you're done. I don't know. It feels very weird to me. It's also kind of ironic that like, at least on the AP test, you have to write code on paper, like pen and paper. Is the weirdest stuff. I mean, I don't like it at all.
Yeah, yeah. Okay, so maybe we can switch gear a little bit. Sounds like we learned about your past journey. So maybe like now we can fast forward a little bit, right? Because let's just say like you're a junior or senior right now, right? Which year are you right now?
I'm a senior.
You're a senior, okay. So you're about to go to college, and you're thinking about the next steps and etc. Can you talk a bit, like what would be your choice, and also like how your past experiences sort of like, like contributed to your decisions,
Yeah, so I guess I'm honestly kind of in the dark in terms of like I think I know what I'm doing, but honestly I'm not 100% sure. I mean, I'm
Yeah.
still kind of second guessing myself at every
Tell
turn.
us a little bit. Tell us a little bit. Like, what are you sure? What are you not sure?
I'm sure I want to do data science
Mm.
in some capacity, or maybe if not data science, then computer science. See, I'm already second guessing myself, but I know that this type of stuff is fascinating to me, and I know that I can jump into a project and pull an all-nighter, not because I'm stressed to turn it in an assignment, but because I'm just so into this thing that I forget that time passes.
Right.
So I know that about myself, and so I want my college experience to allow me to like kind of like work with that. If it does,
Right.
like to me, computer science doesn't feel like work. It feels like I'm playing or I'm enjoying,
Right.
right? It's
Right.
like genuinely incredibly intellectually fascinating.
Right.
And so I want to go to like a school or like a college or something that helps me kind of develop that and works off the fact that a CS assignment is probably not going to feel like work to me.
Yeah. I felt like almost like a traditional college, and if you're just gonna go there, I think you would be disappointed, because I think you're gonna discover essentially like this lecture style and go and do homework and sometimes even writing paper. I think you're gonna find that there's a lot of that, right?
Right.
But I think what you would actually be really really fascinated about is getting into a university where they're doing some cutting edge research that you are super interested about, right? And you can apply the same attitude. You're like, you know what? I tried to climb Mountain Everest from day one. Even though I really didn't really get to the top, I learned so much from doing that. I'm just gonna go to those professors' doors and I'm gonna lock the doors. I'm gonna be like, hey, look, this is who I am. Do you have any internship? Can I join your research group? And then we'll go from there,
Right.
right? Because they are working on some really really cool stuff. I think there's a lot of cool researchers still coming from these universities, and plus your dad is doing something fascinating as well
Oh,
currently,
yeah.
right?
I love that stuff. I'm working
Yeah,
with that stuff. It's just
yeah, yeah.
a
Just
farthest thing I've ever touched with my
yeah, yeah. Can you tell people actually like your dad's company, like what is he's working on? What's the problem right now?
Yeah, totally. So my dad's company is called Syntegra, and what they do is they create synthetic medical data. And so the need for synthetic medical data is actually like surprisingly prevalent. The problem with a lot of like data nowadays in the medical field is that the government like reasonably so protects all the data and all the privacy. So it's really hard to share data with people. So if you can create some sort of synthetic data set that has the same statistical significance of your original data set, but is anonymized, like if it's generated by a computer, it doesn't actually correspond to real people, you can share that freely. And so it's really interesting stuff. Right now I'm working on, there's something that Microsoft is developing called differential privacy, which is essentially a way to determine how, or it's a way to kind of tune how private your data is. I'm vastly oversimplifying here. It took me a while to even understand. The papers are absurdly mathematical and they just destroy my brain. But the thing is that I'm trying to see what the difference is between synthetic data and how private that is versus how private or the privacy offered by differential privacy, and trying to see how they compare and contrast. Essentially, that's what I've been working on the past few months, the past few weeks.
Yeah, I guess another thing you can do is you can almost like do internship at different companies, and they have plenty of problems for you to solve, right?
Yeah, totally.
Yeah. So let me understand this. Let's just say you get into university, okay, and you majored in computer science, and
Yeah.
here we go. We have another summer, okay. What would you do then?
I'm gonna try to get an internship. I mean, I want to apply myself and do something. I mean,
So let me understand this. How would you convince people that you would actually contribute in the internship more than the hours you would demand from someone who's going to coach you?
that's a really good question. I'm not 100% sure how I do that, honestly.
Okay, I can tell you how. I can tell you how. I
Okay.
think one of the things you can do is, first of all, you need to show them this presentation you're doing right now.
Okay.
And second is, you could actually write down, the stuff that you have worked on, right? Whether it's about, for example, the AlphaZero, like the thing you're trying to create, but also, like you are an intern right now working in your dad's company,
Yes.
right? And so once you show people that you can do this, I think there are going to be plenty of people who's going to be like, Daniel, this would be incredible, to work with you, right? And I would say AI Camp would be honored, if we have a chance to work with you, right? So here we go. Then you can always, use, your past experiences, your contribution as stepstones to things you want to do.
Yeah.
Yeah. Okay. I got one more thing. I have a comment. That is, I felt like your journey would be far more enjoyable if there is one more friend who's working with you.
I agree.
Yeah.
Yeah.
It's like, yeah,
Or
go ahead.
something that kind of frustrates me sometimes is that none of my like friends really understand this. I mean, they understand it, and I have some friends who are very technically knowledgeable, but I
Yeah.
don't really have anyone to share this with. I can't ever say like, yo, I just developed this cool thing, check this out or something, or I can like, I always have to kind of keep it to myself.
I got a bunch of people here. Here we got 100 people here. I can just call a few names, and I think those people, they would be like thrilled to work with you. All right. So we got Rohan here. Rohan, Alex, David, Axel. Oh my gosh, we have so many people here. I think if you chat with them, you'd be like, oh my gosh, they were my people. They understand my language. Yeah. So why don't we do the following, right? See, Axel was actually like sending the AI Camp Discord link there. You should just join there, right? And
Yeah.
then we could gradually introduce people to you, and I'm pretty sure you guys can bind together and learn together and build something cool. And maybe it's like this AlphaZero thing. Like, oh yeah, no, you did the Discord thing, right? Discord to classify like the mean comments or something.
Yeah.
That is something where I think there could be like plenty of like these. Oh yeah, you just made me think like we should have AI Camp like bounties. Like we got a bunch of things we need to develop, and we put a bunch of like money or internship opportunities. It's like if you can solve those things, we're just gonna give you that bounty, right? That'd be pretty cool,
That'd be awesome.
And you could have like a few people, right? Like we want to do this, and naturally you're gonna form a team and do this together. That would be really, really cool. Yeah. Okay. So it has been 50 minutes. Wow, this is such a engaging conversation, that I felt like I'm more energized, than I first came in. So okay, everybody, can we please give Daniel a round of applause? Thank you for sharing your journey. Thank you for like going through your journey, telling us how you learn about it, how you tackle all these things. We so much appreciate it here. Yeah. Okay. So before I close it, I want to say, do you guys have questions? Let's open up for questions. We'll have another 5 to 10 minutes. what are the questions you might have for Daniel? It can be anything. Okay, it can be anything. All right, so I think there are some questions. There's some questions coming from the comment section. All right, so I have a question. I'm in middle school and I really like AI. I've been learning Python for the last 2 years. What should I do every day? Like what routine inflow to become good at AI?
That's a great question. What I'll say is that honestly, in my opinion, I don't think you should have a routine. You can. That's totally fine. And if you're that type of person who needs to keep going every day and need to work at something, power to you. For me personally, when I'm interested in something, I just kind of go for it. And I guess it's more of like it's less consistent than like a daily, like I need to go to this article and do this and do this. But when I find something interesting, I just kind of go, I kind of do it. And what I'll tell you is that if you find yourself interested in these things and you want to make a chess engine yourself, or you want to do this yourself, or you want to make whatever, just go do it. You don't need to wait or do a routine or anything. Just, I don't know.
Yeah.
I feel like a routine is not necessary for this.
You need a mental routine, right? It's like
Yeah.
never be afraid of learning those things. Yeah. Okay. Yeah. Got it. All right. So I'm just gonna go down to the order. All right. So Aaron has another question. Can you use AI in video games?
Oh, yeah. I mean, reinforcement learning is kind of used for that. I can show you guys right now if you want. Wait,
Show
can you
us.
see the screen?
Yeah.
Let's see. Let me try looking this up. DQN for like Atari, for example. Let's see if there's any videos. This is and these are like kind of these are like old people games, but maybe not old people games, but like
Yeah.
these are like
I actually showed this in our classes, one of the classes. Yeah.
Right. There's also something called MineRL, which is let's see if this works. Yeah, so they actually I actually tried to participate in this. I didn't do that well, but they trained this well, there's a competition to train an agent to actually go find a diamond in Minecraft. Super fascinating.
Is that a cow?
Yeah. But so yeah, AI can definitely be used in video games.
Yeah. Okay, I'm gonna pick a few questions because obviously there's no way we can answer everything. Okay. Okay. So Madeline has another question. Besides Python, what coding languages do you think are most useful?
Honestly, I'm not sure. I know Python and Java and a little bit of JavaScript from when I was in 4th grade.
Okay.
I'd argue maybe C++ and C are important to know just for the sake of understanding like how computers work and like assigning memory, and like kind of like the lower level languages are pretty useful, and a lot of like the TensorFlow, for example, which is used in machine learning, I'm pretty sure is built on a lower level language, and you just kind of send it information, which it then does in those lower level languages. And I assume if you go to learn CS in college, you will do C++ at some point.
Yeah. So I have a little bit experience here. So I think Python is a language of data. You gotta learn that. It's also like really simple to learn. So learn Python as a first language is a good idea. I think JavaScript is another very useful idea because JavaScript is like there's a saying, anything can be done by JavaScript will be done by JavaScript, right? So whether it's the front end, the back end, AI stuff, JavaScript is everywhere. Okay. The other thing is it's a good idea to learn a language and learn it well than, for example, touching everything, because one language, if you learn it well, it's actually very similar to other languages, right? So, and also SQL, this is something we never taught you guys, but SQL is another language that are super useful, but it's really for like database, retrieve data, doing data analysis and stuff like that. So that stuff, however, it's like you don't have to touch it until I guess you need to. Yeah. Okay. So let's see. Any other questions? Oh yeah. So Aaron's asking, what is the first programming languages did you learn?
Is JavaScript.
JavaScript.
And I remember my first actual, I don't know if I have the file. I think I have my first JavaScript game I made. I used to make games in JavaScript. If you guys remember Cookie Clicker, from like 2013, that was like a big web game that everyone played, and I made my own version.
Nice.
I made Donut Clicker. which is I just ripped images off the internet and had the same mechanic, but yeah,
Right.
it was JavaScript.
That's awesome. That's awesome. Okay. Okay. You know what? Oh, wow, there's so many like these questions coming.
And to
Uh,
people who want to contact me, I can put my I think I'm gonna join the Discord server. I can know if I can chat all, and I can put my Discord in the chat so
yeah.
I can.
You know
Uh,
what? Can you just join the AirCamp Discord
yeah,
community?
well, give me a moment.
And then because when you're joining, everybody else can also just join there and find you, you know?
Let's see. Okay. My name is Daniel Mend on Discord.
Right.
1623.
Meaning you raise your hand. Do you have a question? Okay, could you ask?
So you were mentioning how they could use deep learning to like figure out how to beat like shogi, you said, and Go, like any two-person game. Do you think that this could be applied to games that are much more complicated on a much larger scale? What comes to mind is like a video game like say Rocket League, which is like probably
Oh,
infinite probabilities, but like
I'm champ 2 in Rock. Well, I was champ 2 in Rocket League. I know a lot about
yeah, I'm like Diamond 3 champ 1-ish. So
so the thing about Rocket League is that for the specific the problem with AlphaZero, in my opinion, well, it's not really a problem. It's awesome, but it applies to specific two-player perfect information like board games, where turns are sequential and discrete. In Rocket League, it's not really a discrete space, if that makes sense. You have time is constantly moving, and so you can, and there's not just like you can't just like I mean I don't know. It's a lot more of a complex environment, and AlphaZero's scope is only those like two-person board games where
do you
everything.
think that at one point, because Rocket League is complicated because like there's like an almost infinite like scope of movements and like options and where everything can be at one time. Do you think that eventually we'd have not only the computing power but the algorithms to like make a like AI be able to play it like and learn how to play it with like machine learning?
Yeah, do you know what there's actually a Rocket League bot like community. I don't know if you're familiar with that.
I know I know of it, but do they use deep learning?
There are some bots that do use reinforcement learning. Deep reinforcement learning can be already be applied to those spaces. It's just there's in machine learning there's like the concept of different types of spaces, right? So if I have like 4 different options, it's considered discrete. Or if my option is to like swivel a camera or move my car left or right some amount of degrees, that's like a continuous action space. And so as long as you can like I guess kind of maneuver around those and kind of define your agent such that it like performs in that action space, you can train already existing algorithms on there. But yeah, there are some reinforcement learning algorithms already being used in Rocket League. They're not that great though. They're like flat. But
Yeah, I've noticed most of the bots kind of suck. Like I was talking to my friend about this because I'm not super into coding. I'd like to learn, and so I'm in this class. But like he is, and he was talking about how like if it would be the theoretical possibility of making like an unbeatable Rocket League bot. Yeah, and then I was also thinking like because other video games that are much simpler, like that one guy that like on YouTube, I think his name's like Code Bullet or something. He like he makes like that's machine learning, right? He like has AI learn how to beat like Flappy Bird and stuff.
Yeah. Yeah. Hey guys, I think if we're going to continue this conversation will never end. It's almost like, like there's just so much we can talk about. I see a lot of engagement today. What are we going to do? We're going to do more of these in the future. Okay, we're going to do more of these in the future. We have so many talented students at AI Camp. I think they can all share like, how they learn about AI. And I know that you guys have a lot of questions, and I hope like, Daniel, Rohan, for example, Shahab, and I have so many, familiar faces here that, you would actually like get into the community and help people like learning on their own almost, right? Because we got so many, questions here. It's like, what is the good first machine learning, coding project? There's so many resources I'm pretty sure you used. Rohan, can you tell us like maybe like just one, a few things? What are the most recent projects you have done, actually?
One recent project I did was I applied Minimax in Monte Carlo to Connect 4.
There's so many things, this
and I also created a PyTorch neural network to classify cats and dogs.
You also did the gun stuff, right? Did you?
Yeah. I created generative networks to generate number digits, and I created an autoencoder that also generates number digits.
tell you what, later on, we're gonna do more of these things. And today, because of time, I don't want to hold everybody here. Let's just continue the conversation another time and join the Discord, and you're gonna be in this wonderful community and learn all these things together. Would that be cool? Yeah. Okay. That's it. Can we give another Daniel and another round of applause for Daniel? Thank you so much for this conversation. Really, really awesome. Really, really awesome. Thank you. Okay.
Having me.
Yeah. Okay. All right, guys. Merry Christmas. See you in 2021. Okay. Bye for now. Daniel,
And just
yeah.
good to see you.
Bye.
When's our next meeting?
We'll try to schedule one as soon as we can.
Oh, okay.
Thank you.
Okay. Thank you, Daniel. Bye for now.
Goodbye, guys.
Bye bye.
Thank you.
Bye bye.